Okay, we're starting in the ISN today, and I've given everybody ample time to get their stuff out. You should be ready to go. All right, the hands are representing parallel lines. This would be the interior. This is page 2 in your ISN that we didn't do yet. What is going on, guys? We should have been ready by now. All right, that would be the exterior where I made it blue. Sure. Okay, so I just was going to label that, and it's not even absolutely necessary for you to do this. It's up to you. If you like using the highlighters, I'm definitely going to demonstrate with them. Okay, so now we're going to go down and identify the transversal in the picture. That's here. The transversal is the line that cuts through the other two. Bless you. Okay. Okay, so we're going to name the transversal that cuts through the lines down here and here. This is the same exact diagram. One's a little bit blown up. So transversal is line T. All right, interior angles. So I'm going to highlight that these are about interior angles and where that is. They're inside the two lines. So that's going to be in here. The interior angles are 3, 4, 5, and 6. So angle 3, angle 4, angle 5, and angle 6. Exterior angles are angles on the outside of the two lines. So they're going to be in the blue zone here. At least what I'm making blue. You can use whatever color you want. And don't forget, these do extend forever. So we've got out there, we've got angle 1, 2, 7, and 8. Guess I could have separated these with commas, but who cares? Not a big deal. All right, now corresponding angles don't really have a whole lot to do with interior-exterior naming because they're angles that are in the same position. So one's going to be on the interior, one's going to be on the exterior. I'm not going to color this one. I think I'll just skip that. And just say that angle pairs that are congruent in the same position would be like 1 and 5. Along the transversal, 1 and 5 would be in the same position. Yep, 3 and 7, sure. And then jumping over 2 and 6. And 4 and 8. So those are all your corresponding angles. Now this is what we learned on Tuesday. This is our first day of chapter 3. Then we added in some stuff yesterday which said if the lines are parallel, then there's more properties that we should know. Okay, anybody need this page still? All right, next one. Alternate interior. So I'm going to color where that means. Alternate on the interior, in between the lines. Alternating, meaning jumping over the transversal on different sides of the transversal. So alternating sides of the transversal, making the Z or the S. We talked about it looking like this. Or angles here and here. So in our picture, 3 and 6 are alternate interiors. Angle 3 and angle 6. And angles 4 and 5. Now, since we just did alternate interior, we're going to do alternate exteriors now. So I'm going to show the area on this diagram where those are. They're on the outside of the lines. not in the yellow zone. But they do jump over the transversal also. So you take one from the way outside, one, and jump way over to 8. And 2 is the alternate exterior with 7. Okay. Consecutive interior. Oh, it says interior again. So we're going to be working in between the lines. But this time, they're going to be on the same side of the transversal. So consecutive interiors, also called same side interior angles, are 3 and 5 and 4 and 6. So angle 3 and 5 are consecutive interior, and angle 4 and angle 6 are consecutive interior. The rest are, this is review. So the review is about naming your linear pairs. We have been over this many times, but we still want to make sure that we understand all of the linear pairs in the diagram. These are not enough blanks to name them. 1 and 2 are a linear pair because they form a straight line put together. 3 and 4 are a pair of linear, well, they're a linear pair, 2 angles that add up to 180. 5 and 6, and 7 and 8. But I think someone was assuming we're going to go in the other direction. So couldn't we go this way as well to get the transversal line? So let's add on angle 1 and angle 3, angle 2 and angle 4, and then going down here, angle 5 and 7, and 6 and 8. Okay, any two next to each other that make a straight line are linear pairs. The vertical angles we can easily get, and that's all the pairs that there would be. I'm just going to mark the 2 obtuse. These are 2 obtuse vertical angles. I'm going to note that because I think that's something we should know. The obtuse linear vertical angles are angles 1 and 4, and 5 and 8, and they are congruent. Vertical angles are congruent. Those are all equal to one another. No, oh, actually they aren't, because M and N aren't parallel. So they're just, I'm just saying those are obtuse. So now let's look at some that are acute and vertical. 2 and 3, they're angles that are measured, their measure is less than 90, but greater than 0. Between 0 and 90 is the definition. Angle 2 and angle 3 are acute vertical angles, and 7 and 6 are as well. And you can write 6 and 7 or 7 and 6. Okay, so that's all we're doing for the ISN. So now we have pages, the front page, which is page 1. We have page 2 complete, page 3, and page 4 complete in our ISN. And if you don't, you either need to see the video or see me. Next, we're going to go and look at the ginormous packet you grabbed today that's stapled. It will not take as long as it looks to do it. So I'm going to give you some hints on how to get started, and I have some problems that I've selected to help you with before you try doing any yourself. One of the reasons you got this big packet today is, not because I thought you were going to get it all done, some of the students who actually do their homework are maybe fairly caught up, and they can be working on that if they need to and don't have to ask any questions. The rest of you that need some more help, or you haven't even started on 3.2 homework, which was given yesterday, I'm going to go over some problems on there after I start you off on this. All right, so everybody's got something that they can be doing. This part of it is really straightforward. So let's just look at one problem. I do not care if you do the bubbling at the bottom of the page. I just want you to see you circle your answer. So if you look at angles 1 and 5 in this diagram, you see these parallel lines. Angle 1 and 5 would be corresponding angles. They're in the same position. So you just circle corresponding. I'm just trying to get you to be learning the vocabulary, making sure you memorize it or know it. 2 and 7, if I just jump over to number 3, 2 and 7 are alternate on the exterior. So that'd be C. That's how you do that page. Now, I need you to stay with me because I'm not going to sit here and do all these because that's what I want you to do, to learn. So let's turn, please, you're going to have to turn some pages. There is an example on this page that tells you what to do. It's saying these are alternate exterior angles. You're doing the exact same thing, except now you're filling it in without multiple choice. So you practice learning those words, okay? Keep going. Then you get to this page and it says, okay, good, you're getting faster at it. That's the whole point of this, is to get faster and know the vocab. All right, so this one, you're going to be matching. And that's got a lot of vocab that we need to know that we should be familiar with. So it's not something I should be teaching. Here's where I want you to get to. I want you to get to right here, number 17 and 19. So can you please find the page that has 16, 17, 18, 19 on it? I can explain what you're to do and how to do a couple of them. All right, so on this page, it says on these, state the angle relationship, write a statement about whether they add to 180 or are equal, and find the value. These are alternate exterior angles. This author of this packet said then, of course, you're going to set them equal and solve. What I'm looking for here, I'd like to try to actually get a little bit more out of you in that. You need to know that these lines are parallel to say what you're going to say. So what kind of angles are where the x plus 3 is and the 2x minus 61? What kind are they? They're in the same position, so they're corresponding. So parallel implies corresponding angles congruent. Now you've told me that you know they're congruent and what kind they are. All right, so since they're parallel lines here, you can say these angles are congruent. And I'll just do 2x minus 61 equals x plus 3. Okay, I'll go through a couple of these problems with you. So the first step would be to subtract x from both sides. You get negative. We get x minus 61 is equal to 3. Then you would add 61 to both sides, and you would have x is 64. All right. So that's what you're doing in this section. A little algebra thrown in with the geo concepts. 19, we have parallel lines again, but there's something going on here in the middle. Are these congruent angles? Well, this one is equal to this one over here, the alternate interiors. That's not exactly going to, and so these would actually be supplementary angles. A lot of ways to look at that as to why. Okay, so even since you know these would be equal, these are equal, they make up a whole straight line. That's why these actually another reason why these are supplementary. Okay, so these add up to 180. So what it's saying, parallel implies consecutive. You can write consecutive. I'm just going to write CONS. Interior angles supplementary, SUPP. So these add up to 180. So 2x plus 42 plus x minus 24 equals 180. If you want to just quick add them in your head and simplify right away, that's totally fine with me. You could have done 3x. 42 minus 24 is 18, plus 18 equals 180. And then continue to solve it. So 3 times x is 162. And we divide by 3. You get 54. That's how you do that one. Okay, and then just glancing through the rest. Does anybody still need this? Okay. Thank you. There's just some more stuff to do that's similar and uses the properties. Okay, so then there's this puzzle at the very end, and you getting an answer, and then you'll fill in. They can fill in the crossword puzzle. All right, so I'm done with showing you stuff in that packet until tomorrow. I can answer questions on it tomorrow. What I'd like you to do now is find your packet from yesterday, which is 3.2. This is why I asked you to have all three things out. And I do realize you still have the 3.1 packet. Okay, that's all going to be due next week when we have our next quiz on 3.1 and 3.2. Okay, so we already did all these notes. Can you guys tell me where we were? Did we stop right here? Okay. What I had done before you guys left yesterday was, I believe I highlighted these. Well, I know I did. The parallel lines. Okay, and then I told you that in order to do this problem and to understand it, it would be best if you had highlighters because you can see things. Some of you don't need it, but this is what helps a lot of people visually. Okay, that set of angles is all related to one another. Okay? This set down here is different, and they're related to one another. So before you left yesterday, I said, I'd like you to try these. I told you if angle 9 is 80, find the rest of those angles up there, or whatever ones they ask here, and give a reason. I hope everybody's here because this paper is important. The measure of angle 12 would be, it's adjacent to the 9, and they form a line. So angle 12 is 100 because 9 and 12 form a linear pair, which is by the supplement theorem. Supplement theorem says if two angles form a linear pair, they're supplementary. That 9 and 12 form a linear pair, so they are supplementary. The supplement theorem says so. Angle 1 is going to be, because they gave us angle 9, it's going to be 80. And that's because if you have parallel lines, then angle 1 and 9 are corresponding and congruent. Corresponding angles, congruent. That's how I'll let you write it. That's the whole theorem. It is the corresponding angles theorem. Angle 4. Okay. Angle 4, since angle 1 was 80, angle 4 is 100. You've got multiple reasons you could write. So say you said it's 100, and you said it corresponds with angle 12. You could say parallel implies corresponding angles. Congruent. What's angle 3? It's 80. Now I'm going to use the fact that angle 9 was 80. 3 is 80 because parallel implies angle 9 and 3 are alternate interior angles, and they are congruent. Good luck. Swim team. Okay, now it says angle 7. Is it 80 or 100? Well, why isn't it 80 or 100? Why is, yeah, different numbers down here. We got to remember they said angle 5 is 68. All right, now careful. It's angle 7, yep, it would be 68 because it's vertical with angle 5. So it's just vertical angles theorem. Or you can write, and I wouldn't care which one. If you wrote vertical, and I'll let you do vert, angles congruent, that's cool. That's absolutely fine. That's exactly what the vertical angles theorem says. It says that if two angles are vertical angles, then they are congruent. All right, and 16 is not going to be 68. These can't match right next to each other here. These are supplementary. All right, so it's going to be, we're going to have to do 180, minus 68, which is 112 degrees. And that is because I think we should just go with consecutive angles because 7 and 16 are supplementary because we have parallel lines, then consecutive interior angles sup. SUPP for supplementary. Okay, there's no more on that one, right? There's just a new problem coming up after that. Anybody need this? Okay, I thought maybe, so I'll wait. Ready? Okay, and if anybody needs a printout, you let me know. Find the value of x. Challenge. I need you guys to focus. Look up here. We've been spacing out now. You got to think about things sometimes. Sometimes it's not just straightforward. These aren't pairs of angles that we've talked about. So what could I do? I want to find one that equals one of these and put it there. Okay, what I'm saying is are there any angles equal to this one up here? Like where? Vertical. Okay, that would work. Yeah, you could put it here. Any others? Nathan? Here? Why? Good. That's all I'm looking for, the word. Good. Corresponding. Yeah, these go here. That could go here. Do you see that these form a linear pair? They're supplementary. These also are supplementary because they're same side interior. So that's what we got to do. Now, couldn't you do this? Do you see how many different ways we can say those angles are supplementary? There's a bunch, okay? They have to add up to 180 no matter what we do in the picture. So I just was pointing out that we could have had several people think it out a different way and still be right, okay? So you want to look for things that you can do to help you solve the problem sometimes. I'm just simplifying, and I'm going to leave. You guys can solve this. We've been doing this all year already. All right, so let's see another one. I want to get as many examples in for you. I'd expect you to finish this up. All right, now let's go here because this was confused a lot of people. Because I didn't draw any that had quadrilaterals, four-sided figures. So I'm going to highlight the parallel lines. Okay, now I'm going to look for where there's x's. This is how you got to do problems. Okay, I see x's here and I see x's here. So, and then over here I see y and a number. So I'm going to work with these x's and I'm going to highlight this other piece that makes them. So I've got a transversal in blue and parallel lines in pink here. And these two are on the same side of the transversal. So they're called consecutive interior angles. So they add up to 180. There's your equation for finding x. Not that bad. You have to know how to look at it and give it a shot. Then I'm going to go and say, well, how am I going to figure out y? Well, there's a couple of ways, but let's look over here at this transversal, which is different than this one. So this pair of angles over here is also on the same side of that green transversal. So they add up to 180. 3y plus 18 plus 90 is equal to 180 also. So you're going to solve that to find your y value. Okay. So look at your paper. Do you want to pick another one for me to help you set up? This is your 3.2, which we're trying to get some problems. I'm trying to help you out with some of the problems. The next one. Okay, someone want to tell me what they're going to do to solve for x first? Think about the problem I just did while I highlight. I know you guys can do it. Go ahead, Priscilla. They don't equal. They're going to add up to, so it's like the last problem. They're on the same side of the transversal. So they add to 180. Okay, you see how this one's really wide and this one's small in a way? Okay, so this angle's not as open. There's not as much white space between here as here. This one's smaller than that one. Okay, so they put together, though, give you the 180. Right? That totals up to 180. I hope that helped maybe a little visually. Then on the other side, what do we got? These guys do the same thing. You got the littler one up here and the bigger one down there. These add up to 180 also. So what I'm trying to say is these are supplementary. Here and here, these are supplementary. Okay, so doing the y's, it's going to be 5y plus 5 plus 8, 13y minus 5 is 180. Okay, and you need to solve those. Don't forget to simplify before you start doing algebra subtractions and adds and all that stuff. Oh, these wiped out. The 5s cancel each other out on this part. Okay. And you should know, subtract 4, divide by 16, and the last one will be 10. All right, I've got another awkward one to work with you, which is 10. That's what I need to pay attention to on this diagram. Okay, there are multiple ways to do a couple of the things on here. However, the first thing is to find x. You see the z? Those are alternate interiors, so they're equal. So 5x minus 20 equals 3x. Now, to solve that one, we're going to have to subtract 5x. And I kept saying in my other classes, I went ahead and said, well, wait a minute. Some of you may not have written it in that order. You may have written the 3x first. 3x equals 5x minus 20. Alternate interior angles are congruent. That's why we're doing it. So we're going to need to subtract 5x from both sides. And sometimes we get confused when this happens. 3x minus 5x is negative 2x. And then you have to bring down the minus 20, which is negative 20. And sometimes we forget to do that and we get a negative answer. This should actually turn out positive, which is kind of important. And since these have to be positive angle measures, we get 10. Now, substitute that back in here. How big was the angle where the 3x is? And how big was the angle down here where the 5x minus 20 is? Okay. So now we're looking for a way to find y. Right there's a 4y. Okay? I'm separating it out so you can see what I'm talking about. That's where the blue line is and the pink lines. All right, and then up in the corner, look what we got. We have 2y and 30 up here. in this big corner. What do those angles add up to here and here? That's the same side supplementary. They add up to 180. So now I'm going to explain it another way because I wonder if anybody saw it. You see that triangle there? What do the angles of a triangle add up to? We've talked about it, although we haven't proved it. 180. Do you see how I can get 2y plus 4y plus 30? That's exactly what I got here. 4y plus 2y plus 30 equals 180. So any way you look at it, that's how we have to solve for y. Unless somebody said, well, if that's, no, I don't want to do that. I just want to do it this way. So 6y plus 30 equals 150. And then solve for y. Okay, so as I pause a minute, and I'm going to go to another problem. I have a couple more I want to show you, and I want you to be thinking. So please look at 20. I'm leaving the rest of this for homework. I was really curious if I could get someone to think this out with me. Okay, so I'm not just going to tell you right this second. First, I'm going to suggest what this means. An auxiliary line. I want to add a line that's not in the picture that would help me. Guys, please try to think. I know it's getting late in the day, but this is how you learn better. I don't like to just always tell you if I can help it. I want some ideas from you. An auxiliary line means you get to put one in here wherever you think it'd be best to put it in. So it would help you find angle 1. You want to find angle 1. There's your hint of where to maybe put it. It wants to be parallel to these. Now, that's your next hint. It needs to be parallel to those. Okay, I think I know what you're saying, but bisect isn't maybe the perfect word, but I think I know what you mean. You wanted me to draw a line right here? Chloe? Draw a line through angle 1 is what I think you meant as well. Okay. Yep, that would be it. All right, so we're putting a line in there, and we're going to say we drew a line parallel to the other two. You're allowed to draw a line that's parallel to those two. Sorry, these are just arrows. Oh, man, I'm wasting time. All right, now, thinking caps. What kind of angle is here and here? Those are corresponding angles. So by the corresponding angles theorem, or the fact that if you have parallel lines, corresponding angles are congruent, this is 50. Okay, so think a little more. I got 100 down here. Where else is 100? Way up here? Up here? No, I won't go there. Because this is under, but that one is not the same line like that one. Here? These are corresponding. Yep, so this one's 100. I think a lot of you saw that. Okay, now, the measure of angle 1 then, we just figured it out. We're going to put together 50 and 100 to get 150 degrees. Now, this is a real application of using this. People can find a lot of things they need to do in the real world in building, etc., using these kind of ideas. Have you ever heard of a plumb line? They pop a piece of duct tape to make another parallel line. That's working with parallel lines right there. It helps you with equidistant things, etc. So we got a lot of cool stuff in geometry that's out there in the real world. All right, 21. One more. I want another auxiliary line. This one's going to be a little different, guys. But we know where we're putting it, right? Right there. Oh, not very parallel. I don't like my line. Well, I think I'll just get rid of my line. I'm sorry. I'm being a little too perfectionist. I got my tool out here. It should do a little bit better at drawing. Oh, well, that's even worse. Okay, we know what's going on, though. So I'm going to say that line is parallel, the other two. And that's what these fat arrows are, guys. They mean the lines are parallel. That was a really awful drawing for me, but here we go. Now what? Okay, so maybe I need to be a little more careful about how I'm explaining this, in that this transversal is one we're working with, and it's separate from that transversal. Okay, so working up here between these two parallel lines, how big is this angle right here between the pink and the green on my picture? 62 degrees. Okay. But here's the trickier one. How big's the angle underneath the 62? Right here. What's the relationship between this one and 144? Those are consecutive, oh, I can write, interior angles. So they're not congruent, they are supplementary. So we've got to figure out 180 minus 144. And that's 36. So this angle's 36 degrees. All right, now we put those together, and the measure of angle 1 is 62 plus 36, which is 98 degrees. Well, I hope you will practice problems in your 3.2. Look back at your 3.1. Make sure you're getting it done. Maybe do a little in your 3.1, 3.2 packet. Tomorrow we have a shortened period, so we will be doing, and that's just for this particular year, if this is a future listening. We're going to be working on 3.1 and 3.2 combined. Have a nice evening.